we'll start with the first problem now. So this is a continuous beam which is simply supported at A, B and C. A, B and C. So the type of load is UDL on this side, and on the another side also there is UDL. Intensity of UDL is 30 kilonewton per meter, and here it is 25 kilonewton per meter. This length is 6 meter, this length is 5 meter. So now we have to analyze the continuous beam. So first write down the given things. So in given, it is a continuous beam, then W1 is 30 kilonewton per meter, W2 is 25 kilonewton per meter, L1 is 6, L2 is 5 meter. Next step is to find. So what we have to find? So we have to analyze, that means we have to draw the shear force diagram and bending moment diagram. So to draw this, first we'll start with marking the center points here. So A, B, C, and then this is D and E. As we know that to draw the net bending moment diagram, we have to draw here two diagrams first. First is the free bending moment diagram, and the second one is the fixed bending moment diagram. So as UDL is present on both sides, so here a parabola will come. Similarly here also there will be a parabola. So now how to find out the height of the parabola? So we'll write here in free bending moment diagram, moment at point D is equal to, so height for parabola is WL square by 8, so it is 30 into 6 square by 8. Similarly moment at point E, UDL, so WL square by 8, 25 into 5 square by 8. So upon calculating this, MD should come as 135 kilonewton meter and ME will come as 78.125 kilonewton meter. So this is 135 and this is 78.125. So now using Clapeyron's theorem, to start using the Clapeyron's theorem, first we will have to write what is the Clapeyron's theorem. So it is MA into L1 plus 2MB into L1 plus L2 plus MC into L2 is equal to minus in bracket 6A1 x1 bar by L1 plus 6A2 x2 bar by L2. Okay, so this will name it as equation A. So one by one we'll write all the values here. So the value of MA here, free end, so 0, L1 is 6, L2 is 5 meter, moment at C is also 0. Now the area of the first diagram, that is this area. So to calculate this, we'll use the formula 2 by 3 times of AB. So 2 by 3 times of 6 into 135. Similarly A2 is also UDL, so 2 by 3 times of AB. So 2 by 3 times of 5 into 78.125. So this first calculation will give us the value of 540. This will give us 260.42. Now in the equation everything is cleared, only x1 bar and x2 bar is remaining. So x1 bar is the distance of the centroid from point A. Similarly x2 bar is this distance. So from the diagram you can say that x1 bar is 3 and x2 bar is 2.5. So we'll write here x1 bar is 3, x2 bar is 2.5. Now substituting all values in equation A. So if we substitute all values, this will be 0 into 6 plus 2 MB into 6 plus 5 plus 0 into 5 is equal to minus 6 into 540 into 3 by 6 plus 6 into 260.42 into 2.5 by 5. So this is 0, this is also 0. So this is 6 plus 5 11, 11 into 2 22. So 22 MB. This calculation will give us the answer of 2401.25. So MB is equal to minus 109.15 kilonewton meter. So this we can also write it as, this negative sign denotes the hogging moment. So instead of this we can write it like this, 109.15 kilonewton meter hogging. So we have got the value of MB, we know MA and MC, so we can draw the fixed bending moment diagram. So for drawing the fixed bending moment diagram, this is the first point, MA is 0, MB is 109.15 and MC is also 0. So connecting it with the straight line, so this is the fixed bending moment diagram. Free bending moment diagram is sagging, so positive. Fixed bending moment diagram is negative. Now net bending moment diagram. So to draw the net bending moment diagram, we have to combine the first two diagrams, that is free and fixed. So first free bending moment diagram. So this is 135. So this is 78.125. And this minus 109, this we will draw it on the upside. Now this is all positive and this is negative. Now there are two important points here, this point and this point. So F and G. So this F and G are called point of contraflexures. And what is point of contraflexures? Where the bending moment changes sign. So you can see from positive to negative it is happening at point F, and at point G from negative to positive. That means bending moment changes the sign here. So hence it is called as point of contraflexion. This is 6 meter, this is 5 meter. And this is our net bending moment diagram. Now, so we'll move for the shear force. So while calculating the shear force, first you draw the given beam. So this is 30, this is 25, 6 and 5. Now whatever the movements you have calculated, you have to mark it here. So what is the value of MA? It is 0. What is the value of MB? 109.15 and it is negative 109.15. Okay, so this is also 109.15 MB value. MB and MC is also 0. So what are the reactions at A? We'll name it VA, VB and VC. So first we'll consider, okay, this step you name it as shear force calculation. Shear force calculations. So first consider AB. So we'll only consider A and B. This is VA, and at B there is a moment that is 109.15 and UDL is present here, that is 30 and this is 6. Apply sigma MB is equal to 0. So if you apply this, sigma MB is equal to 0, we'll get, and we'll assume clockwise positive. So VA into 6 minus 30 into 6 into 3 plus 109.15, this is equal to 0. So the value of VA is 26.81 kilonewton. So this is the value of VA. Similarly, now consider BC. So consider BC. So while considering BC, so this is VC, this is B, and there is a movement direction. You have to note it from the figure only, and this UDL is 25. Same, apply sigma MB is equal to 0, take clockwise positive. So this is minus VC into 5 plus 25 into 5 into 2.5 minus 109.15 is equal to 0. So while calculation, after calculating this, you will get the VC as 40.67 kilonewton. Okay, now at the last, so this is the first one, consider AB, BC. At last you consider the overall beam, that is consider ABC. Now in this ABC you only apply sigma Fy is equal to 0. So if you apply this, all the upward forces VA plus VB plus VC, that is equal to total downward force. So 30 into 6 plus 25 into 5. So VA is 26.81 plus VB plus 40.67 is equal to 180 plus 125. So after calculation you will get the value of VB as 237.52 kilonewton. This is the value of VB. Now we have to draw the shear force diagram. Once you have calculated all the shear force, then you start drawing the shear force diagram. So first we'll draw the zero line. VA, what is the value of VA? 26.81. so 26.81 will move upward. This is 26.81. now 26.81 minus 30 into 6, so this will give us 153.19. so the next point here is 153.19. you connect it with the straight line, as UDL is present, so this will have to connect with a straight line. Now what is the value of VP? 237.52. so 237.52 minus 153.19, so it will push the shear force diagram in upward direction. So this will be 84.33. 84.33. Now 84.33 minus 125. 84.33 minus 125 will give us 40.67. So this will give us 40.67. And at last, what is VC? This is 40.67. That means everything is correct. Now whatever the zones are there above zero line, that is positive, and this is negative, and this is our shear force diagram. Okay, so solve it 2-3 times. First, calculating these reactions is important. Once you calculate the reactions, then drawing this is a piece of cake. Okay, so how to calculate the shear force? First consider AB, then BC, and then ABC. So while considering AB and BC, pay attention to this direction of the movements. Okay, so this is how you have to denote the directions of movement. We have calculated the MB here, so after calculating you denote this MB in this way. Okay, so this is how we have calculated now the net bending moment diagram. We have also drawn the net bending moment diagram and the shear force diagram.